Okay, today's lesson is 3-1B of exponential functions. So we're going to be talking about solving problems involving exponential growth and decay, aka real world problems. Now, the key, one of the really important things that you need to remember about these is whenever you do it, to determine which formula you're going to use, you need to determine whether it's periodic or continuous growth or decay. And that's not a hard thing to do if you can read, because the only thing you have to do is look for this word continuously when you read the problems. If you do not have the word continuously, you do not use that formula. And I think y'all seen this formula down here before, PERT. Okay, so the one that we're going to talk about first, compound interest formula, looks like this. You have seen this before. Okay, what do you need to know about it? You need to know that P is how much you invested and how much you started with. You're going to need to know what R is. It's your interest rate, and you always have to put it as a decimal. You need to know how many times something is compounded a year. And in this formula, y'all, it's talking about interest. It's a compound interest formula. So N is always in terms of a year. If you have 6 months, you're going to have half a year. You don't put 6 in for T. Okay, and balance A is what you have at the end after T years. Okay, so in this first problem, financial literacy, if $1,000 is invested, that's going to be my P. In an online savings account earning 8%, that's my R. That's the 1% that we're going to change to a decimal. How much will be in the account at the end of 10 years if no other deposits or withdrawals and interest is compounded either semi-annually, quarterly, or daily. Okay, so what I'm going to do is really set it up and show you the difference of what's going to happen in these problems. So in this first one, if I'm going up here and I'm just using this formula and I'm kind of color coding the way I'm putting things in there, so you'll see where the blue is going to go, where's the green going to go, where's the orange going to go in the formula. So first off, for semi-annual, I'm going to have A equal to something. So all of that stays the same. Okay, this is what's going to go first here after the equal sign is how much I invested, which was $1,000. On top of my fraction bar is going to be my interest rate, which is 8% as a decimal, 0.08. Underneath is how many times it's compounded each year. And semi-annual is compounded twice a year. So that number also goes up there. And then what's left up here is how much time elapsed, how many years, and that is 10. Okay, so before I go on, I want to show you what's the difference in quarterly. So if I go to quarterly, the only thing that changes is my N value, and quarterly means it's going to happen 4 times a year. So I'm going to 4 there. And daily, the accepted number for daily is how many days are in a year? 365. So we're going to have 365. So I put each of those in a calculator, and I stopped at this point because I want to point out to y'all, if you miss this in your Delta Math when you're doing these problems, number one, if you don't have a calculator where you can see exactly what you put into the calculator, it's not really worth much these days. So between ClassCalc or the calculator in Delta Math, I use that one to see. You would see it exactly the way you put it in there. So you get to put it in your calculator just like this. You will get a decimal. So you will either miss it because you didn't put the numbers in correctly, because I don't think you're going to have trouble setting it up, but actually inputting into the calculator, or you're not going to read the directions and round properly. Okay, most of the time with money, we round to the nearest cent, dollars and cents. So we want 2 places on each of these answers. Okay, so just keep that in mind, because I go through and do these problems before y'all do. And I know sometimes he has you round things to the nearest whole. Sometimes you round them to the nearest tens. So pay attention to the directions. If you get it wrong the first time, look at what you've put into the calculator and what your rounding is. Read the directions. Okay. In the PERT formula, okay, we've got the same thing. P is my initial investment. I'm still going to have R as my interest rate as a decimal. My A is my balance at the end after T years, okay? But you can see it's PERT, so it's a little bit different, okay? And I read this problem, and I can see the word continuously. If $1,000 is invested in an online savings account earning 8% per year, compounded continuously, how much will be in the account at the end of 10 years if there are no other deposits or withdrawals? So in my formula, I'm going to have A equals P, which is the amount I invested, $1,000. It's always going to be an E, and R is my interest rate, which is 0.08, and time is still 10. So the difference here, plugging in your calculator and again rounding, so you can kind of see the difference is not that big. We had the same amount every time. We did 10 years, but what changed was how often it was compounded. And you clearly make more money when it's compounded continuously than you do the other times. Okay, that was money. That was interest and money. And now we are going to talk about exponential growth and decay. So this is type of problem that doesn't have to deal with money. Okay, so if you see the two formulas that I've highlighted, it's very similar. That's like my A, that's like my P, but we aren't going to have any compounding over here. And over here, they use the letter K to represent that growth rate. And again, they're using N and N sub 0. N sub 0, y'all, 0 is the time when T equals 0. So when T equals 0, that's time 0. That's the initial time. So if that helps you remember that. Okay, so our initial quantity is N sub 0. We have our rate, as I just said. We have our final amount N, and our time is T. Now, this is the difference between this and the other formulas that we have. And you really got to pay attention to this in Delta Math. Okay? But time can be any unit in these exponential growth and decay. So you could have days, weeks, months, minutes, seconds, years. It can be years. You just have to read the problem and pay attention to what it says. Okay, so our first real world example, population. The population of a town is declining at a rate of 6%. Okay, pay attention to declining. Okay, so we'll keep going. If the current population is 12,426 people, predict the population in 5 and 10 years using each model. So I'm going to do the two models using 5 years. Okay, so when I plug it in, so this one annually means I'm going to use just, exponential growth and decay. I'm looking for the ending amount. And what have I done? I used A instead of N. I know y'all can handle that. N sub 0 is my initial amount, which is 12,426 people. My rate is 6%, which is 0.06. But the key here, y'all, is that it's minus because it's declining. Okay. And my time, in this case, 5 years. So that's going to be a 5 up there. Okay. How is that going to be different? If it's continuously, I used A again instead of N, my bad. I still have the same initial people, but this time I have E. And because I am declining, I'm going to have a negative 0.06, and my time is still 5. So when I plug my numbers in, okay, and I'm rounding, in this case, y'all, predicting population, we can't have a fraction of a person. So this makes sense. But again, you don't have to worry about that in Delta Math because he will actually tell you what to round to. So I'm going to round it to the nearest whole because that's what people are. So those are your different answers. Okay. All right. This last problem, I'm doing this because this is some of the problems that you have to do in your homework. Use the data in the table and assume the population of Miami-Dade County is growing exponentially. So they give us a nice little chart here. In 1990, it was 1.94 million, and in 2000, it was 2.25 million. Okay. They want us to identify the growth and write an exponential equation to model this growth. Okay. So I am going to be using that formula, N equals N sub 0, 1 plus R to the T. Okay. Now, when I plug these in, I'm using the information from this table. And to simplify things, y'all, you can use 1990 and 2000, but it's a heck of a lot easier if I let this be N sub 0. So if that's N sub 0, then how much time has gone by from here? Well, you can see that's 10 years. And then these are my amounts. So that makes this my initial amount and this my final amount. Okay? Because I'm trying to find the growth rate. So I'm going to plug in 2.25 for N, 1.94 for N sub 0. And then I have my 1 plus R. I'm looking for R because it asked for identify the rate of growth. So I have to find R. T, of course, is 10 because there's 10 years between 1990 and 2000. So the first thing you want to do is divide by the 1.94. You have to get rid of that because you have to get this thing all by itself. So when I divide by 1.94, I get that lovely decimal. And this, I know y'all know that you're supposed to get rid of the 10 in the exponent. I'm going to take the 10th root of both sides. And the 10th root of that decimal is that lovely number. So 1 plus r is equal to that. And then I subtract 1 to solve for r. So r equals 0.0149. And that is not the rate of growth. That's actually the decimal. So to give it as a rate, I would have to move that decimal point over 2 places. And my rate is 1.49%. They asked us for an exponential equation to model this growth. And the thing that makes it a model would be to keep the initial amount and to keep the rate. So when I write that, n equals, I used the n correctly this time, n equals 1.94 times 1. I went ahead and added 1 plus that decimal. It's this right here. See, that's 1 plus r. So that's what I put in right here because you always want to simplify your model. Okay, that is all. If you have any questions, please don't hesitate to contact us or come see us. Thank you so much for watching, and y'all have a great day.